Welcome to part 5 of the Trusser tutorial videos. We're nearing the end of finishing up this truss. If you'll notice that I've kind of left it looking exactly how I did at the end of the last video. Kind of fix it. I'm going to change the pitch parameter back to a 3 just so it'll look somewhat kind of normal. The last thing that we need to do here is to place the joint boxes. The joint boxes are a tool that Trusser uses to decide where exactly the metal plate connectors need to go. I guess the easiest way to understand this is that it is a finite area under which the computer program estimates if a metal plate will actually work or not. Otherwise, we'd be dealing with the whole Cartesian planes, so we just decided to establish a bounding box so that to kind of ease the calculations and make it run a little faster. So kind of start doing this, you need to pick a joint. I'm going to start with J. Notice that J symbolizes this joint right here. If you use the arrow keys, you can move the box around. If you hold shift and use the arrow keys, you can size the box, make it bigger or smaller. If you'll notice, there are, for every time I move something, you can notice that the values change over here on the right side of the screen. These values can be manually entered, but it's a lot easier just to, see it and do it. I have no idea what size bounding box I'm going to need or anything like that, so I just use shift and kind of play around. Really, the only rule when dealing with these bounding boxes is that you don't want the top of the box to extend past the outside of the truss, and you don't want the bottom box to extend below the truss. So J, this thing right here looks kind of good. One other note is that the dot here, this blue dot, the center of the box should almost always be kind of on your joint line. I kind of feel a little more comfortable if I move this one down there. It kind of is in the intersection of the board and the center of this. Now, if you'll notice that J, I have J selected, I can copy J. It copies all the information here, and then if I go over here to F, I select F and hit paste, then I get an exact replica of that joint box. It's really important to do that because if you don't, then even the slightest variation can cause Trusser to calculate a plate over here and a different plate over here. Using the same bounding box guarantees that the same plate is calculated for both spots. Moving on to B, notice that this joint box has a little red line on top of it. That red line symbolizes that when I calculate the top, the plate will be fixed to this red line. So it'll has to be on the red line. Now if I do left, then now it'll be in this corner and it'll work its way out. If I pick all of them, fix all the edges, then the plate will be as big as the box no matter what. I tend to like to leave Trusser to just decide where the plate should be on its own. It's perfectly capable of doing that, and so I just leave it kind of open. There are particular cases where you might want a certain edge fixed, but we're not going to run into one of those on any of these. So I'm going to copy B, move it over here to D, and paste. I'm going to do the same thing for I. I'm going to give I kind of a bigger bounding box, because there's a lot of wiggle room in here, but notice that it's okay for it to extend into the open space in the middle of the joist, the truss, but it's not okay for it to extend past the bottom. I'm going to copy that, paste over into G, and I get a replica. H needs to be fixed, it's our splice point. I'll give it a wide area, and then C also. C is actually kind of good, as Trusser likes to kind of guess how big the bounding box might need to be and give you one, but I'm not going to want that top edge fixed. We'll extend it, make it a little bigger, and give it a lot of room to copy. So now looking at it, all of our bounding boxes are set. We're done basically with our joints menu. So we'll move on to the analysis. I'm going to go ahead and continue the analysis in this joints menu because there's not a lot of detail to go into it. The main thing in the analysis, you can change how you want how to analyze, like what you want to set your building specifications for. But Trusser automatically picks the standard specifications, so I'd always just leave them as is. If you go down here for supports, this is how you're actually holding your joist up. So you know that there's going to be some type of support right here at point J, and then also one type at point F. Now, if you're in the industry or studying this for a class, and you probably know that one end of a truss is normally pinned and the other one is normally placed in a horizontal roller. That's what these two options indicate. And we are now done creating the template for this truss. The only thing left to do is to hit run analysis. And as I hit this, if you'll notice, the boards seem to have disappeared. What's really happened is that they've gone from the geometric model into an analog model that'll then be used to allow the mathematics to do their work and figure out where the plates actually need to be placed. So as this happens, you'll see that we get this blue lines instead of boards. These blue lines indicate they're the elements, they're the physical representation of they're the representation of the physical model of those boards. We don't really see a lot of interesting things going on here. If you'll notice that this is kind of a purplish, it gets a little redder in here as it does down here. This is just indicating as the blue line goes from kind of this blue right here to deep red, that means that you're getting more and more stress in that board. There's a certain point where it gets so red that you need to upgrade the quality of the lumber. Basically, if you kind of look here, you can see this blue, and you can know that this is probably 0% of the stress that this board take. But then, say we go in and throw, I don't know, 100 pounds per square foot, run the analysis, then we'll probably get a lot of red coming out. We'll let it run down here. It's going through its test cases. Yeah, notice that the board's changed pretty drastically. There's a lot of deep reds in here. That's because these boards are most likely overstressed. But if you'll remember, I changed the building. I changed what I was analyzing it with. The loads that I was analyzing it with before were, a fifth of what that 100 pounds per square foot load. So to get out of this blue kind of menu, you can hit elements. And if you look, these gray squares have appeared. Elements is down here. This is your kind of display box. You can turn everything on or off, just kind of depending on what you want. So let's turn elements. We'll leave the grid and we'll turn the points and the lines off. And if you look here, we have a symmetrical truss that Trusser has, accurately calculated the optimum plate size for all of these things. Another interesting thing, kind of just going a little bit further, is if you hit J, you'll bring up a joints menu. Sorry, that was a little off window. It's going to be kind of hard to show you this. Let me see if I can make this a little smaller. No, it's fixed size, so I'll just have to pick joint B over here. If I click B, you'll notice that we get color schemes. The orange right here corresponds to this orange area over here. Then you can note that you see a area required, and then the area plated, and then the difference. If you see down here, then we're getting 5 square inches, 4.5 square inches over what we actually need. But before we kind of freak out and think, why is it doing this? if we go over here to joints, you can notice that it says vendor, and for joint B I pick CH machine. That's indicating that's the vendor list that we want Trusser to search through to find adequate plates. The smallest plate that CH Machine manufactures is a 2x4 plate, which is what has been placed here. It's not a fault of the program that there's so much more area being plated. It's simply a fact that there's no smaller plate for us to purchase. I guess with that, we're finished with these tutorials. Hopefully they've been helpful. If you have anything that you'd like to add, please leave us a comment. If there's anything that we could improve for you, please leave us a comment. From Trussoft, thank you very much, and we hope you enjoy using our program.